Hey everyone, how's it going? This is Siri and I'm back with another PyTorch video, and we're going to be continuing our discussion again on tabular data. We've been focusing on tabular data for the past few videos now, and I actually think that this is going to be our last video on tabular data, and you can look forward to time series next. Okay, so let's cover one last thing. So this is just working with tabular data. I'm not going to be passing anything in. We didn't do anything with images either. We'll do more of that sort of stuff when we, really talk about neural networks and the different layers and things like that. But in this video, we're going to be talking about finding thresholds. Okay, with our wine quality data. Okay, so what does that mean? What this means is I want to know what's that cutting point where we say, hey, everything above this value is good, everything below it is bad. Where's that cutoff mark where we distinguish between the different qualities? So that's how thresholds would work in this sort of situation. And I guess maybe if you were talking about house price regression, then maybe if you were building an application that could tell you, hey, what are the available houses that are on the market under this sort of threshold, right? So that's maybe another area in which you would find the threshold. Okay, so we're just going to be going about that process, getting a feel for it, and getting a feel for how we do it in PyTorch. Okay, so when we separate this sort of data, we do it based on a condition. Okay, so that's basically like an if statement or like a condition. Actually, it's not an if statement. It's like a conditional value. It's a Boolean value, right? Where we compare different values, right? When we say 5 is greater than 3, if we do that in a program, then we're going to get true. Okay, that's the Boolean value. And so we have, first of all, let's print out target.shape. And target is just the output values. That's the answers of our model, right? Like that's what we want to predict. But since we are dealing with data and we need data to predict, we have our targets, which we would most likely hide and during our testing phase after we've trained it. And so, okay, let's not get into that now. But okay, I guess I have to run this all over again. Okay, let's run it. Okay, great. That's what we expected. I think we printed this value out multiple times. This just tells us the number of rows in our wine queue. Target is just, a tensor with those values. Not with all of them, not with all the columns, just the values for each of these things. The quality, not each of these things, I mean just the quality. That's the overall thing that we want to predict. So what's our threshold going to be? So let's just say that anything or any wine that has a quality of 3 or lower is bad. Okay? So we predict the quality based on all of the other attributes. So that's the target once again. And let's say that these are the bad indices. Okay, so these are going to be the indices of that wine that has the index of the wine that has a quality of 3 or lower. And you get that index, and using that index you can access, hey, what are all the attributes that made it bad, and you can examine that if you wanted to. But pretty much you would basically leave that to the model, most likely. Okay, so let's take a look. So let's say that target, that's less than or equal to 3. And you can do the comparison operator like this. Just like you could do something like this. Say, let's say BL for Boolean. I can't say bool because that's like a bool val. Say 5 is greater than 3. And then we print out bool val. Oh. And then we print out bool val. True. We switch it. We get false. Okay, so we can do that in Python. Okay, and we can do this with our tensor too, because it does it element wise, and since we have these many elements in our tensor, it's gonna go to each value in the tensor and say, hey, is this value less than or equal to 3? If so, set the index equal to bad indices. Okay. And since it's a tensor, we're gonna have like let's check it out. We're gonna have a tensor too. Okay. So yeah. Let's check out bad indices. Dot shape. Bad indices. Dot dtype. And bad indices. Dot sum. So what does this do? What does sum do? Sum tells us how many elements, or like the sum of all the elements in the tensor. So when we print it out, sum gives us sum of all elements in tensor. Okay, we run it. We get, first of all, we already knew the shape. The type is a bool, like we expected, right? And because we're doing a conditional here, and so if it's like if it satisfies this condition, the value is going to be true, and if it doesn't, it's going to be false. And so when we have a tensor filled with ones and zeros, obviously if you take the sum, you're going to get a result of however many true values there are, because each of the trues are ones, right? Because that's how Python stores these Boolean values. Python stores trues as ones and falses as 0. So that's why when you do the sum of bad indices, you're always going to get the true values, because false is just 0. It doesn't contribute to the sum. So yeah, so these are how many values there are in true values there are in bad indices. And bad indices has the same shape as target, except now they're just zeros and ones, like I said. Okay? So let's take the mean of each column. Okay? Let's say that bad data is something, and then middle data is something else, and then good data is like the best of the best wine. Okay, so let's say data. Did we define data? I'm pretty sure we defined it to be everything but the target column. I think we did that last time. Yeah, everything, all the rows, all the data samples and all the columns except for the last target. We don't need the quality, right? We just want to know the actual characteristics of it. And so if the target is less than or equal to 3, and here data, the target is greater than 3, and okay, let's put some parentheses around this, and target is less than 7. So that's like medium or like average, middle, and anything that's above 7, above or equal to 7 is good. Okay, so we run it. Okay, let's check out the size of each one. Print bad data. Print mid data. Print good data. Dot shape. So, they're all the 11 columns, right? Because we're excluding the target. Okay. Bad data has 20. Okay. Bad indices had all of them, but bad data just has 20. Mid data has these many, and good data has those many. So if you take a look at this, plus 20, we get the total number of rows. Okay, so this is the distribution of the different types of wine, like the different types of quality of wine. And so this is what I mean by finding thresholds. Like there's a threshold to what we call bad data. There's a threshold, there's a cutoff for our middle data. There's a cutoff for our good data, except for our good data is going to be on the lower side, the lower bounds, right? Because there's nothing above it. And so, yeah. So let's check out, first of all, the type of data. It's a tensor. Type of target. Tensor. So what are we doing here? We're saying, okay, this is a tensor. These are basically like indices, right? For all the ones that are less than 3. Okay? That was bad indices. That was also a tensor. So what did we demonstrate here? We demonstrated, this is actually a pretty important point, and it's pretty interesting. We can index tensors using tensors. Isn't that interesting? If you look at a Python list, can you index a list using a list? No, you can't, but you can with tensors, and that's really interesting, and that's really helpful to us. And the reason this is the case is because it does it element-wise. When you add to lists in Python, you just concatenate them. However, when you do it with tensors, you do element-wise addition or subtraction or whatever. Okay, it gets distributed among each of the individual elements, which is why which is a similar idea of why you can, index tensors using tensors. Okay, and yeah, let's take the mean of each column. Okay, with like bad data, middle data, and good data. Let's say bad mean, let's say mid mean, and let's say good mean. What are we going to set it equal to? Let's set it equal to torch.mean. okay, bad data, and the dimension is going to be along 0. So when you see the shape of bad data or good data or whatever, the dimension 0, which is just the first one, tells you, how many bad wines are there, how many medium wines, or like average wines are there, how many good wines are there. So we're taking the mean based on that part of the data, okay? Not the columns, because that's constant, right? That's the same for all 3. So when you run that, and let's do this little program. It's just gonna be a little for loop, and we're gonna print out some information that's like visually appealing to us. Not gonna be any visualization, but we're gonna organize it in a way that's that it makes sense to see it in. So let's say for I args in enumerate. Okay, zip. Okay, column list. Bad mean, mid mean, good mean. Okay. Let's print out don't worry about this. This is just like some of the formatting. You can search up what these different things mean actually, if you wanted to. But it's not that big of a concern that you should worry about. So you can either do an f string or the older one, dot format. I'm just going to be using dot format for now. The newer one is the f string, right, where you can just format your string. Args. Okay, great. So what this crazy but not too crazy thing did was that well, you can see it here, right? I don't need to explain it to you. You see the numbers, you see the indices, you see the different attributes, and yeah, you see the top values. Okay, so column list, bad mean, mid mean, good mean, for each of the different attributes. So for fixed acidity, we have 3 different means. We have the average of the fixed acidity of the bad wines, the average wines, and the good wines. We have a mean or an average of the volatile acidity for the bad ones, the average ones, and the good ones, and so on. So that's what we did there. And so let's talk about something else that's really important to this threshold concept that we're considering. And that's the idea of torch.lt. And this computes the input, whether the input's less than the other argument that we're going to be passing in or not. Okay, and it does this element-wise, as expected. Okay, this whole thing revolves around the idea of doing operations, performing operations on different values in the tensors and the corresponding values in the tensor. So it's no surprise that we see a lot of things that are being done element-wise. All the addition, subtraction, all of these different things are done element-wise as well. Okay, so let's check out the sulfur. Okay, let's say total sulfur threshold is, you know, maybe like just total sulfur dioxide 170. Okay, yeah, 170. So 170.6. Oh. Okay, that's the value that we see here in the average. Okay, is this a markdown? Alright. Okay, great. And so let's say total sulfur data is equal to data, all the rows, but just the sixth one, right? Because the sixth one is total sulfur dioxide. And let's say predicted indices, and you'll see where I'm going with this in a minute. Torch.lt, total sulfur data, total sulfur threshold. What am I doing here? So we said that torch.lt computes the input of, it computes this Boolean value. This is a Boolean, right? We saw here with, even with regular Python stuff, that if we set bool val equal to like a comparison, then like 5 is either less than 3 or not less than 3, and it's not, so it's false, right? And we did that with tensors too, and that's what we're doing here. We're saying whether each corresponding element of the input, which is the first argument, which is total sulfur data, whether each of those values is less than each of the values in the other. What's the other? The total sulfur threshold. So we want to see whether it's under the threshold or it doesn't meet the threshold. We want to see how many of them do. Okay, so we're using this as a basis for our predictions. Okay, it's not that great to base our entire quality prediction just based on this one attribute, this one feature. But we're not there yet, and we're just gonna be we're just gonna see how this goes and how this turns out. So if it passes the threshold, then yay, we made a good prediction. If it or actually no, if it passes the threshold, then we're gonna assume that it's false, and if it doesn't, then obviously it's gonna be true, because that's just the way this works. And so let's check it out. Let's say predicted, okay, well, first let's run this and say predicted indices dot shape predicted. Okay, basically I'm going to do the same thing here as I did here. Except instead of bad indices, we're going to be using predicted indices. Okay, great. So once again, the sum is just going to be the sum of ones because the zeros don't contribute, and the ones represent true, and so we have these many true values. So these many values for the sulfur were in fact less than the threshold. So that's good. And yeah, so the actual indices are when the target's more than 5, which just means it's above average, right? If you set it to be equal to greater than 5, then we're just assuming it's average because there's 10 of these. There's 11, but it starts at 0. So if we set it to the first 5, then we have 6, 7, 8, 9. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. Okay, whatever. Yeah, so if we say like the actual indices. Okay, so these are the really good ones, which just means it's above average. So let's set it equal to target greater than 5. Okay, this is a tensor once again. And let's basically do the same thing here. Okay, so these are the actual good ones. And this is the prediction. These are the predictions that we made just using the sulfur. So we wanted... Okay, so what did we do here? We set the total threshold equal to 170. We have all our sulfur data, and we're saying set all the values. Okay, predicted indices has everything. And if it meets the threshold, okay, if it's less than other, okay, if it meets the threshold and if it's true, then we have 1. So for each, if it passes the threshold, and if this is true, then we're assuming that the quality of the wine is good, okay, because it's not greater than like the mean, okay, and that's our prediction. We predicted 3,783 based on the sulfur alone. But the way we actually want to classify good wines are maybe like if it's greater than 5, the quality is greater than 5. So how many of those are actually greater than 5? Well, we have 3,200, 3,258. So we were off. We predicted more, actually. The last time I ran this, it was like 1. The middle values were different. I'm surprised. Oh my goodness, I made a mistake. Excuse me, I said bad data for every single one. Okay, this is so ridiculous. Yeah, we have different values now. So it's actually 141.83. And the threshold was the average value. So if it's better than average, then it's, then it's good. It's good wine. If it's not, then it's not. And so when we run this, we predict 2,700 good wines because they weren't greater than the threshold. That's what the true values are. And the actual ones that are actually greater than 5 are 3,200. And so we were about, so there are actually 500 more, like, good wines, or, like, decent wines. so let's check out how we did. Let's say n matches. So let's see how many of ours actually matched. And so say torch.sum actual indices and predicted indices. And dot item just turns it into a scalar value. And predicted is equal to torch.sum predicted indices dot item, and an actual, so predicted and actual. So it's gonna be torch.sum actual indices dot item and matches, comma, n matches dot, divided by how many we actually predicted. So this is just printing values out. N matches over n actual. Predicted indices. I didn't say m matches. Okay, so what's going on here? Since we predicted 2,700 wines here, if we predict a wine to be high quality, there's only like 74% chance that it actually is, and we only identified 61% of them. So that's what these calculations do. So matches divided by predicted. So if we predict it to be high quality, then there's a 70% chance that it actually is, and we guessed 61% of them, of the actual ones. Okay. All right, great. Sorry for the mistake here. It might have been confusing. I didn't know, for some reason I didn't notice that they were all the same values. So I didn't catch the mistake here. So yeah, the mean of the bad data should be of the bad data, not the middle data or good data. And so it's important that we don't forget. Okay, so these are all the average values. Just a recap, these are all the average values, and we set the threshold to the average value, because that's like, you know, the gold standard in our early days, since we're not that familiar with neural networks just yet, right? So if it, based on that threshold, we're going to make some predictions, and let's say that the actual indices, not just based on the sulfur, but the actual indices are when the targets are greater than 5, and then we see how we did. Okay, so that's setting a threshold, but this is just to get a feel for it, because we're not actually going to be doing this in real life, right? We're not going to be setting thresholds for each of our values in the neural network, because that would take way too much time, and it would just get way too complicated, beyond imagination, right? Like, there's so much going on. And so this was just an example to see like how we might go through analyzing data. And so yeah, I hope you learned something new today about finding thresholds, and I guess this wraps up our discussion on tabular data, and I'm looking forward to seeing you next time, where we're going to be discussing time series, so you can look forward to that. Alright, thank you so much, and don't forget to like, comment, and subscribe.